Hello, it is me, Miss Thomas again. I'm going to first start by going over your homework answers to make sure y'all are clear on that. So let's get to it. So your amplitude is 3. Don't forget there's a reflection here. Okay, even though our amplitude really is none. Okay. I think the few people that did turn this in so far have gotten that completely correct. Actually, y'all did wonderful, the ones of you who turned it in, so that's great. Okay, so our period is going to be 2 pi over 2, which is going to be pi. So then we can go ahead and label that. Okay, and then we have our 3 and our negative 3. All right, so secant is the reciprocal of cosine. So cosine starts up here typically, but it doesn't on this one. Why not? Because it is a reflection. So it should start down here, and then we have our asymptotes on every other tick mark, if you remember. Okay, I'm going to use a different color here so it'll stand out. Maybe even like green will be good. Okay, so then like cosine, if we if we reflect cosine, it makes a M instead of a W. That's kind of what we want to see here. So then it's going to go like this. And so we'll go like that, and like that, and there, and there. So all of these parabolas down here were originally facing up, and these up here were facing down, but the reason they're not like that is because of the reflection. Okay, y'all make sure y'all are okay with that. Pause if you need to go back. All right, so our amp is none, but our quote-unquote amp is 1, which is no change. Okay, from the parent, there is a reflection. And then our period, that's our B right there. So our period is going to be 2 pi over 1/5. And do keep, change, flip. So 2 pi times 5 over 1. So our period is 10 pi. So we're going to divide this by 4. So 10 pi divided by 4, that's what it's going to look like, but then that can simplify. So 5 over 2, because you can divide both of them by 2. Okay, then we're going to divide 10 pi by 2, which gives us just a nice 5 pi. And then we're going to times 5 pi over 2 by 3, which will give us 15 pi over 2. That one's a little weird. I don't think we've done anything with that number. So if you got those tick marks, that means you really understand it, which is awesome. Okay, let's put in let's first talk about it's the reciprocal of, since we have a C, we need an S, which is sine. Sine typically starts here on the x-axis, but we know we can't do that anymore, so our asymptote is right here, and then every other one. Now, because this is a reflection, and it maps with sine, or it kind of looks like sine. Sine typically goes up on the right here, but because it's a reflection, it's going to go down on the right, up on the left, and then, ooh, that was pretty bad. And then we can get our parabolas drawn from there. Okay? And then lastly, number 10. You know, I didn't say this on the first one. This should be a vertical stretch. I think we're cleared with that. And then this, and that's because A is greater than 1. Here, your B is greater than 1, so it's a horizontal compression. Remember, they're like opposite of each other. Okay, so this doesn't really change with period. I guess I'm just jumping right into it. I should show the work. So let me go back. So our amp is none, but our quote-unquote amp is 4, which is a vertical stretch. And then our period is just going to continue to be 2 pi. All right. And cosecant is the reciprocal of sine. Okay. So let's get a different color. Every other one, if y'all notice, I'm doing the asymptotes first every time. I just try to get the asymptotes set, and then I can think about the tick marks, okay? So we just did cosecant here, but it was, so it's going to be similar, but it was a reflection here. This one is not. So it is going to go up on the right. Down on the left. And then it does the opposite. Okay, so those should be your homework ones. Now we're going to go to the new stuff. Okay, so we're going to learn the last 2 graphs, which are tangent and cotangent. So they also have asymptotes. I'm just going to you're just going to kind of have to trust me. I would typically have like a graphic organizer and have us go through that in class, but just to kind of get us good with time, I'm just going to kind of show you what tangent looks like. Okay, so tangent looks like a graph you should have seen before. It's called a cubic. So it starts down here at -1, 0, and at 1. So it kind of makes this like curve. All right, it's like a cubic function if you've seen that or heard that before. Then you have asymptotes, 2 to the right. And what I mean by that is like 1, 2 tick marks. That's what I mean. So 2 tick marks to the right and then 2 tick marks to the left. So you have an asymptote, then you have, it starts down, then goes to, let me use a highlighter so I can show you what I'm talking about. Okay, so asymptote, then it starts down, and then it goes to the midline, and then it goes to the top. So it's an increasing function. Okay. And then we just start that pattern over again. So it's going to start down. It's going to go up. Now we only need, remember how we've always done like 4 tick marks? So technically like this next tick mark, we know it would go up here, but you don't really have, that's a little high. You don't have to draw that additional tick mark in. You can just draw it without that dot. Okay, so technically this is how I would like for it to look. Like that. You know the other dot's going to be up here somewhere, but you don't have to put it. And then you're going to do the same thing on the other side, but it starts, so it's kind of like you're looking at the end of the graph. You don't have this beginning point down here. There's no need to plot it because we don't have that tick mark, but you know that's what it would look like. Okay? So there is a few things that we want to note here. Okay, so the first thing is the amplitude for the tangent graph is always going to be none. It's the same reasoning as before. This graph is going to go up forever and it's going to go down forever. So you're never going to be able to have a height. Okay, so the amplitude is always going to be none. But again, like we did, we can do like a quote-unquote amp to get the vertical stretch or vertical shrink. Now the period here is actually, it still takes 4 tick marks. See, if we start here, that's 1, 2, 3, 4 tick marks for the graph to repeat itself, because then it's going to start and do the same thing over here. However, our tick marks are not the same. Okay, so this is a little different, and I want you to make sure you really make note of this. The period is actually pi. Okay, so our 4th tick mark is pi every single time with tangent, unless we have a period change. And so then we'll go through, we're going to divide by 4 to get the first one. We're going to divide by 2, and then we're going to times the first one by 3. Okay, so if I were in class, I'd really make you pull that highlighter out. This is very important because it is different from all the other graphs. We're used to seeing 2 pi every time, but it's pi, and I guess I should also say that it would be pi over b is your period. Okay, that formula. All right, so you need to kind of memorize this. You see why this can get a little tricky. Now, it doesn't look anything like secant and cosecant because, like, it doesn't have the parabolas, but it has asymptotes. And so sometimes that's where students can get confused, is like, well, where does the asymptote go? For tangent, it's 2 to the right and 2 to the left, okay? Of the y-axis, I guess I should say that. All right, let's talk about cotan. So cotan is the reciprocal of tan. So we're going to kind of talk about what we did with secant and cosecant 2 days ago on Monday. All right, so if we were to take this point here on tangent and reciprocate it, it's still going to be at 1. Okay, so this one's going to be at 1. Now, if we reciprocate a 0 point, that's like this, you remember, which equals undefined. So where this graph was touching at 0, it's now going to be undefined. So that means we have a dotted line here. Okay. And then where this graph was undefined, like the asymptote here, well, you can kind of do the opposite. So if it was undefined, that meant the 0 was on the bottom. So if we flip it now, 0 is going to be on the numerator, which means it's going to be 0. So it's going to be there. And then this point here at -1, if we reciprocate it, it's still going to be in the same spot. And then if you go back up here, if we reciprocate 0, it's going to be undefined. Oops, I didn't mean to make that bigger. So, long story short, if you didn't really fully understand what I was just explaining about you know, getting this graph, that's really okay, to be quite honest. You just really need to know what the shape of the graph is. So let's try to do the same thing on this side and note the differences. Oh, sorry, that was pretty ugly. Let's see if I can make that better. Not a whole lot better, but that's okay. All right, so let's note some differences. So see how this graph is... Nope, sorry, that's not what I wanted. See how this graph is increasing? It's going up. Notice what this graph is doing. It's decreasing or going down, okay? So tangent is going to increase while cotangent decreases. Also, I like cotangent a lot better because the asymptotes are right in the middle and right on the ends. So you don't have to remember like 2 to the right, 2 to the left. You just remember middle and ends. And it's 2 nice full cubics. So it means it's 1 full one going down, another full one going down. Now I'm going to erase all that so it doesn't look confusing. Okay, with tangent, it's 3, well, technically it's 1 full cubic, and then you have this one with 2 points, and this one with 2 points, but we kind of know where the third point's going to be, so we can anticipate what the graph is going to look like. Okay? So we need to make sure this graph kind of is memorized or written down. I guess you don't have to memorize as much when you have your notes in front of you. And so now we can write like the amplitude and all that stuff. So the amplitude here is also still none because they go down and up forever. There's no way to put a height on that. And your period is going to be the same as cotangent, so it's pi over b. So pi divide by 4 divide by 2 times the first one by 3. Okay, so y'all make sure you get those down. Get this tangent one down if you need to go back, and then get this cotangent one down so you can kind of know. And I would just say the biggest thing is making sure you remember this, because when we put them all together shortly, like in a little a few days. When we bring back sine, cosine, secant, and cosecant, you're going to have to remember 2 pi over b, but with cotangent and tangent, you use pi over b. Okay, I need a drink. A sip of a drink. I do not need a drink. I just need a sip of my drink. I need to, my husband's laughing at me in the background. I'm going to do a couple examples with you, 4 examples, and then you're going to do 3 on your own. Yeah, 4 examples. Okay, we're really just going to focus on amplitude and period changes. All right, so our amplitude here is none, but our amp is 3, which would be a vertical stretch. So you can vertically stretch these graphs. It's just a little harder to tell. We're still going to keep going to 4 tick marks to the right and to the left. You just have to remember that this one is going to be pi. The period is going to be pi. Oops, I should have written that down, because your imaginary 1 is here. Okay? So then we're going to have pi over 4, pi over 2, and 3 pi over 4. All right, so tangent had asymptotes, if you remember, 2 to the right, 2 to the left, and that's it. So we don't have to do like every other one, like secant and cosecant, just 2 to the right and 2 to the left. And so now we can plot. So if you remember, I'm going to kind of start down. Now I'm starting at -3 because of the whole amplitude or vertical stretch. And then it's going to go to the middle, and it's going to go up to 3. So basically it's going to look exactly the same. It's just going to be a little more straightened out, sort of. Okay, and then we'll repeat that process. So start down, middle. We're not going to plot that 3rd point, but we know where it goes, so I'm just going to go up like so. Sometimes this left side is a little difficult because you got to think you're kind of at the end of it, so you're starting at the top and going down. And you're kind of anticipating the graph to go that way. Okay, pause, go back if you need to. I'm going to keep going. All right, so our amplitude is none, but our amp is 1/2, which is a vertical compression because A is less than 1. And then our period is now going to be pi divided by 2. Okay, because our formula was pi over b, and our b is 2 in this. Okay, so 1, 2, 3, 4. We're going to put pi over 2, and we're only going to go up to 1/2 and down to 1/2. All right, so if we divide this one by 4, it's going to be pi over 8. If we divide that by 2, it'll be pi over 4, and then 3 pi over 8. All right, then cotangent is the one that's nice. It has the asymptotes right down the center and then perfectly on the ends. Okay, but instead, like tangent, this one was an increasing graph. We want cotangent to be a decreasing graph. So we're going to start at the top and work our way down. So it should be that curve, but it should be decreasing. So starting at 1/2, then the 0, then -1/2. Okay. I hope I didn't miss anything. I think we got it all. So there's what that graph should look like. Now let's talk about what reflections are going to look like. So our amplitude is still none, but our amp is 1, which is no change. And our period is going to be pi over 1/2. Remember, there's an imaginary 1 here, which is going to equal 2 pi. So actually, that's going to turn out to be like what we're used to. So 2 pi, pi over 2. All right, so the asymptotes, even though we are doing a reflection here, the asymptotes stay put. Okay, so let's make note. All right, so now cotangent, if you look at this previous example, cotangent was decreasing. So if we reflect it, whatever's going to be up top is now going to be at bottom, and whatever was at the bottom is now going to be at top. 0 is going to stay put because it is on the axis of which we're flipping. So it's now going to be like an increasing graph, if that makes sense. Okay, so basically instead of it decreasing, it is now going to increase. So I'm going to start at the bottom, middle, and then go up. Whoops. So it kind of looks like tangent, the way that it increases, but notice that the asymptotes are still in the same spot. So bottom, middle, up. And then you do your best to make those zigzags. Obviously, I'm not a pro at it. Okay, so asymptotes stay in the same spot, but the graph increases as opposed to decreasing. All right, and now let's do one last one. Let's change up the color. Okay, so our amp is none. That's going to get old, but it is what it is. All right, our amplitude is 3, which is a vertical stretch. And then we need to remember reflect. Okay. And then our period is going to just stay pi because we have an imaginary 1 there. So it goes pi, pi over 4, pi over 2, and 3 pi over 4. All right, so with tangent, our asymptotes are going to stay in the same spot. So with tangent, it was 2 to the right and 2 to the left. And so now we can kind of get the graph set. So if we want to scroll back up and look how tangent looked. All right, so it should have 3 cubics and it's increasing. Well, if we're making it negative or reflecting it, it's going to decrease. Okay, so instead of starting down here, we're going to start up here. 0 is going to stay in the same spot, and then it's going to go down this way. Okay, so it's going to be a decreasing graph. So then it's going to start back at 3, go to 0. We're not going to plot this point down here because we know that's where it's going to go. And now we have to think backwards, okay? So this is the end of the graph, which means it's going to be the low part, and then up, and then the high part's going to be over here. Okay, so if you know that I went a little too quickly, go back and pause, rewatch it a few times if you need to. And here's your homework. I would like for you to try those 3 problems, submit it to me so I can give you some feedback. All right. Have a good one. We'll chat later.